Handout 4, Representing Proportional Relationships. Practice representing proportional relationships in multiple ways. With the following examples, use the representation given to help you fill in the others. So in this first one, we are given a verbal description that says the student council is selling t-shirts to raise awareness for the local animal shelter. For each t-shirt they sell, they will donate $5. So if X represents the number of t-shirts sold, and we can see that down here in the table, and Y equals the dollars donated, we know that they will donate $5 for every t-shirt. So if we multiply the t-shirts times $5, we will get how much they are donating. Okay, so our equation is easy to write that way. Now, we also know that the 5 in our equation equals K. So now let's fill out the rest of the table. So we know that Y needs to equal 5 times X. So if we sell 0 t-shirts, or the student council, they donate $0. If they sell 10 t-shirts, we just put that in our equation and times it by 5, and that means $50. 20 t-shirts, they'd sell $100 or donate $100. They sell 30, they're donating $150. 40 is $200, 50 is $250, and 60 is $300. Okay, so we can put that over on our graph. We're going to use the information from our table to label our X and Y axes and give the graph a name. So this is going to be dollars donated to the animal shelter. All right, now our y-axis represents the dollars donated, and our x-axis represents the number of shirts sold. That comes directly from the table, okay? Now, we know that if we sell 0 shirts, we donate $0. If 10 shirts are sold, $50 is donated. 20 is $100. 30 is $150. Notice I'm just taking the information right off of the table that we have created over here, and the X values we find along the X-axis, and the Y values we find along the Y-axis. All right, that's all for that one. Let's answer some of the questions that they are asking us. Describe how you know that the above situation is proportional. Well, there are 2 ways. One, the graph goes through the origin. The graph goes through the origin, or 0, 0. Okay, and 2, there is a K of 5, or a constant proportionality. In other words, y divided by x always equals 5. So in number 2, where it says find the constant proportionality, we know that y divided by x could equal anything like, let's do the 200 divided by 40. That equals 5. Okay, what does the rate of change represent in this situation? Well, the rate of change is $5, and that's just the same as our K. So 5 equals K equals the rate of change. So for every 1 shirt sold, $5 is donated. You could say that backwards too. You could say for $5 is donated for every 1 shirt. Okay, number 4, what does the ordered pair 10, 50 mean? So our X's are the 10 and Y is 50. So since X is shirts, that would mean that if 10 shirts are sold, because 10 is the number of shirts sold, $50 is donated. Okay, if a student council sells 80 shirts, how much will they donate to the animal shelter? So we can use our equation, y equals 5x, and we can replace the number of t-shirts with 80. So we get y equals 5 times 80, which equals $400. So $400 will be donated. We need to answer the question with a sentence. Okay, let's move to the back page here. Okay, so in the first problem, we are not given a verbal description, so we'll need to fill that in. We are given that y equals 3x. In our table, we can see that x is the number of hours and y is the number of pumpkins. And then in our graph, we are told that Jack's decorating, or Halloween decorating, and can paint a certain number of pumpkins in a certain number of hours. So we need to figure out how much that is. So we can use our y equals 3x. We can put that in here. Y equals 3x to fill in our table. Now, we can, in 1 hour, we can do 3 pumpkins. In 2 hours, 6. 3 hours, 9. 12, 15, 18, and 21. So that tells me in 1 hour, I can make, or Jack's Halloween decorating can paint 3 pumpkins. So my K is when x equals 1, so this is also equal to k. I also can find that right there in my equation. So my verbal description would be that Jack's Halloween decorating can paint 3 pumpkins per hour. Now I can use the information on my table to fill in my graph. So at 0 hours, Jack's Halloween decorating has painted 0 pumpkins, but after 1 hour they've done 3, 2 hours 6, 3, 9, and I can use that pattern of going up 1 over 1 to fill in all the way to 10 hours. All right, now let's move down to the last one. In this one, we are given, we are not given a verbal description or even an equation. Our table tells us that x is hours and y is miles, and we need to figure out what y equals. And in our graph, we are told that the Jaguar's daily movements are going to be represented on this graph, where y is the miles traveled and x is the number of hours. And I'm going to say that is hours traveled. Okay, so in our chart over here, we can see that we have 2 filled in. So if he goes 6 hours, he has traveled 9 miles. If he goes 12 hours, he has traveled 18 miles. So first I need to find what is k. So I need to do y divided by x, or 9 divided by 6, which equals 1.5. Now I can use that 1.5 to do my equation of y equals kx. Because y divided by x equals my k. I know what my k is. So y equals a rate of 1.5 times x. Then I can finish filling in my table. So 2 times 1.5 is 3, 4 is 6, 8 is 12, 10 is 15. And now I can just use these points to fill in my graph. So when x is 2, y is 3. So if we find x is 2, we know that y is 3. But we can do that much prettier. We don't need to put all those lines in. So x is 2, y is 3, x is 4, y is 6. We're going to skip over 3 because it's not on the table. X is 6, y is 9. If he travels for 8 hours, he has traveled 12 miles. 9 is 15. Oh, no, 10 is 15. There we go. We got to skip one. All right. Now we can put in a verbal description. Okay, we know that the Jaguar moves 1.5 miles every hour. Doesn't have to be fancy or difficult. The summary of today's lesson is just that we can represent, we can represent proportional relationships on graphs, tables, with equations, or word problems. And we only really need a little bit of information in each one of them.